Welcome to Ask and Learn.
Hello everyone, in the figure it is given the crank rotates about the point A with angular speed. So angular velocity of crank AB is given 900 rpm in clockwise sense. So this can be written as 30 pi radian per second in clockwise direction. Length of AB is given 50 millimeter, that is 0.05 meter. dB is given 150 millimeter, that is 0.15 meter. If theta having the value 120 degree, then we have to find acceleration of the piston. Now let us start solving it. First we will draw a geometrical figure of the given. This is D point, this is B point, this is A. This angle is given 120 degree. This angle assume beta, and by using the sine law we can find this value. Sine of beta upon 0.05 is equal to sine of 120 upon 0.15. So beta will be 16.8 degree. Now we will do velocity analysis of the system. Angular velocity of AB is given. The velocity of B point, we can find AB into omega AB in the direction AB is 0.05, omega is 30 pi. So you will get 1.5 pi meter per second in this direction. Now velocity of D point is velocity in downward direction, and angular velocity of BD is in anti-clockwise sense. Velocity of D with respect to B will be dV into omega Vd in the direction dV, you know, 0.15. So velocity of D, we can write velocity of V plus velocity of V with respect to D. Now substitute the value. Velocity of D is given downward. Velocity of V, you know, 1.5 pi meter per second in this direction plus 0.15 omega Vd in this direction. Now taking the component of this along it positive, so you may write minus 1.5 pi cos of 60 minus 0.15 omega Vd cos of beta to be 0. So omega Vd is negative of 1.5 pi upon cos 60 divided by 0.15 cos of 16.8. So on solving it, this value you will get minus 16.4065 radian per second. So in vector form, you may write 16.4065 radian per second in counterclockwise direction. Now acceleration analysis. Acceleration of AB is 0. Acceleration of V point AB omega square AB. AB is 0.05, omega square is 30 pi, and direction is so on solving it, this will be 4044.13 meter per second square along this direction, which is shown in the figure. Now acceleration of D point will be acceleration of D in the downward direction, and angular velocity of Vd is in clockwise direction. Now we can find acceleration of D point with respect to B point, acceleration of V plus just a moment, acceleration of D with respect to V, so alpha dV into alpha dV in the direction this plus dV omega square dV in this direction. Substitute the value. dV is 0.15 alpha dV. Direction is marked. dV is 0.15 omega square dV. This would be the direction. Now we can find acceleration of D point will be acceleration of B point plus acceleration of D with respect to V. Acceleration of D point is downward. Acceleration of B we have calculated 444.13 meter per second square at angle 30 degree. Substitute these value. Acceleration of D with respect to B 0.15 alpha dv plus 0.15. This value is known 40.376 square. Now you can resolve it into components along left hand side and right hand side. So component of this in this direction should be taken positive 0 minus 44413 cos of 30 plus 0.15 alpha dV cos of 16.8 plus, on solving this, it is sine of beta. Here I have to do the correction. So from here you will get alpha BD will be 2597.0 radian per second square. Now component along this line to be considered positive. So you will take minus 44413 sine of 30 minus 0.15 alpha BD already we have calculated 2597.0 sine of 16.8 plus 14.376 cos of 16.8 and this is AD. So acceleration of B point you will get 296 meter per second square, and it is given acceleration of P is equal to acceleration of D, that is 296 meter per second square in downward direction. So this is the answer for this problem. Thanks for watching it.